So this is a Book Nook or a Book Nook or a Book Nook or a Book Nook. I don't know what it is, but it fits on a shelf and it provides a little world that maybe relates to some of the books that you have. They've been really popular, especially over the last few years. So this is one that I made, as you see, made out of plywood, laser cut. I bought the plans off Etsy. I'll share them here. I'll share them below. But the trouble is with these is that now when I've got the lights coming in from above, they're really clear, but it's quite hard to see what's going on inside. And I mean, you can just put fairy lights and cheap little lights on the strings in there, but I always wanted something a bit more interesting. So anyway, in this one I've got an Arduino and it goes through different times of the day and does different lighting effects. So you can see some of it here on this video. Got different LEDs in different places and it fast forwards the day, a bit like in Minecraft. And over a period of time it goes from sunrise to midday, then to night, and sometimes you're even treated to random lightning at night. Now in my previous video I played with this Unihiker and I thought what a great project for this, to have something where you can set the time of day on this, you can set the various lights that are happening on it. Maybe if you've got special effects lights in various places, you can have that so that the Unihiker controls them and the Unihiker's attached to it. So that's what this video is about. And you see the first thing you're probably going to need to do is do that. Just see at the back there, I've got a little, that LED ring that I was playing about with earlier, that sits there at the top. And so we can light that up and do various effects inside our Book Nook. So let's have a look at the Unihiker and see how we can do this code. Sometimes doing content creation can be so frustrating. Just spent the last hour and a half writing some Python code for this project, and as you see here I did a lot of work on that, but unfortunately for some weird reason the camera didn't record the audio. I've spent a fortune on mics that do record and I didn't hit record on that either. Anyhow, I'm just going to walk you through this code now and show you what it does as opposed to creating it for you. So let's just walk through this code. You can get this code on my GitHub. Let's set up the Unihiker. Since the last video I decided to chop one of these Grove connectors up that I got with it. If they are Grove, if they're not Grove, please let me know in the comments below. And I've just soldered those directly onto there. Saves me messing about with the breadboard. So that will go into there. I don't have to worry about any of the connections going wrong now on the breadboard, which is good. So in the last video we'd taken some of the demo code, and remember I'd got the buttons controlling these Neopixels. So now we've got to make that work a lot further. So I'm just going to run the program and let me show you what it does. So when it starts, it will do the startup swizzle there, as we did previously. Just through red, green and blue, and you'll see I've done lots of different buttons on it. Each of these buttons represents a different colour and it will scroll through these colours. Originally we had 3 colours, red, green and blue. Put these into an array and I've actually put lots of different colours in there. I've put 11 different colours, so I've got max colours there, 11 for that, and I've actually done a colour name that's related to each of those colours. And if you notice, I've named the colours as if it's scrolling through a day, as if it's different lights on the day. So it starts at dawn with reddish tones, which go to orange, gets much brighter towards pure white during the day, and then fades into a bluey for the moonlight at night. Each of these colours, I mean, we can see the example here, red, green, blue for black. They're all set to 0. That's black, that's fine. So you can set each of these colours in an array. And I think these are called tuples. Please let me know whether I'm right or not in the comments. Each of these tuples represents the RGB colours. So you see here for this first one, this dawn one, the red is at 98, the green is at 90 and the blue is at 70. I've set some more variables up here. Tick, this will be the smallest time unit that this program works, and we'll count that tick at various times. So we'll count the tick for this timer, and you see we've got two modes that the program's going to be running in. So how this is going to work, it's going to start off at a color, and then it's going to hold that color for a while. That will be at wait mode, and then it will change to the fade mode, and as it's in the fade mode, it will move through a set of colors to get to the new colour, the future colour. All right, set the ring up. Here's the bit that just does the red, green and blue swirly at the start. And then here's the bit that adds all the buttons. Now you notice here, because I've set all these in an array, here, this is the index of the array. So if I look back at here, we've got these colours. Index 0 is the first one in the array. Always starts at 0 for an index, which will confuse you completely from time to time. Always does with me. And that represents here index 1 of the colour names, which are text strings instead. That represents black there. So I've just got a human readable form and then the computer readable form to get the values there. Each of these buttons, so you see I've got a button called black. When I define that button, the text on it, I just say colour name 0, which will give me black. And then the index of what's been clicked as well gets passed through to the code that changes things. I have to do that quite a few times to get all of the 11 buttons on the page. All right, we're still in the startup mode here. The very first thing that I do after the startup, we've done the red, green and the blue. I reset everything to the first colour, which happens to be black on this. So it means after that startup spinning round, you start off with black. And you see, while I've been talking, this has moved to a bluey, cyany sort of colour now, which hopefully you can see on the video. You might not be able to. Apologies for that. All right, so what happens when we click? So when these buttons click, what it's going to do is it's going to jump out of this sequence. So the sequence just moves down this sequence here. So it moves from black to dawn, back to sunlight, fully at the noon, and then it begins to blue off throughout the day until it finally goes back to black again. But what we can do, you see, it's a very bluey one now. If I push a button, it will reset it back to the different time of the day. So I set it off to very sunny, or I can set it to a dawn there. The dawn 2 actually is a bit redder, so yeah, that looks more like dawn. So we can jump around red to the blue. So this is the program working. So every time you hit the button, it comes into this bit. It gives a bit of diagnostics. So as you see down the bottom, when I'm clicking the button, it says change to noon. It does that by using that lookup on the color with that index that comes in off the button. And what it does there is instantly it sets the current color to the future color. It sets the timer back to 0 and it puts it into wait. So as soon as you do that, it goes into wait mode no matter what we were doing previously, and it sets the colors to the ring there. Okay, so that's the only thing that happens in the button event. It's quite simple as it appears on there, but now all the work has moved into this main loop. So if we look at the main loop now, we've got the two modes. We've got the mode equals wait and the mode equals change. We'll start with the mode equals wait because that's much simpler. So when we first enter this loop, after we've just pushed the button, we've reset everything. We've reset the timer to 0, and you see there, if timer is 0, then print holding at. So it's holding that color. It goes to sleep for the tick, which if you remember was 0.1 of a second, a tenth of a second, and it increments the timer. It will then come back to this loop and start to do it again because it's still in this wait mode. As we're incrementing the timer, when it gets to the max wait, which up here somewhere, what did we set that to? Max wait at 50. When we get to the max wait, if we go over that value, we reset the timer to 0 and we set the mode to change. So if you read this, really, the wait mode does nothing. It just waits until it counts up to 50. It will keep on looping until it gets to 50. At that point, it resets it to 0 and sets the mode to change. And we'll see on the change as well, at the bottom of that, we've got a similar thing that once that gets to the maximum fade value, it will keep on adding, ignore this other stuff for the moment, but it will keep on adding to the timer. And then here it says, if the timer is greater than the max fade, do something with the colors first to make sure the colors are set to what we were trying to get to, increment the future color and go back into wait mode. But different things happen when you enter the fade mode. So let's go and have a look at that because this is where some of the maths happen. As soon as we go into change mode, the first thing that we do is wait a little bit longer. All right, so the change things takes a while to start. So I'm multiplying that tick by 10. So let's look at what the tick is again. I think I got it wrong when I said it earlier. No, the tick is 1/10 of a second. When we enter the fade mode, the first thing it does is just wait. The first time we go into change mode, the first run through the loop at timer 0, we're going to do this. So we're going to look at what the current color is. So we're looking at the colors array, taking what the current color index is. So let's say it's 1, and then looking at the first color value within that. So coming back to this bit here, we take in the first value in the colors array, which will be that, and then we're looking at these individually and looking at the first index there, which is going to be 0 on black, but maybe this one is a bit better, so it's going to be 98. So the red component of this is 98. So it does that for the current color, which is what the color it should be at the moment, but it also does the same thing for the future color. The future values are what we want to fade to. So we've got a version of red that's 98, and maybe for the future color it needs to be 62. So we get those values first, and then down here to get the red, we take one away from the other, which will give a positive or a negative value, and then we divide that by the amount of fade steps. So we remember max fade was 20, so there's 20 steps. So whatever that 90, 92 to go to 62 is, it divides that by 20, which gives us a smaller number, and that goes into the delta. So we'll do that for the red, we'll do that for the green, we'll do that for the blue. So we've got a smaller number, which could be plus or minus. All right, we do some diagnostics. We say what we're doing to. Remember, this is the very first time the loop comes through. Now we go into the main fade loop. So as soon as we enter that fade loop, we set the LEDs to whatever the current values in those are. So current red, current green, current blue. Then we take those values and we add the delta to them. So this is where we're adding. It could just be current red equals delta red. So that might take that 92 value and add, well, it will take away on that if you're moving down to 62. It might take 2 away from that, let's say. Because we're dividing, it might be 2.4. So we're still going to do that, whatever that value is. But then because the LED ring has to have integer values, it has to have whole numbers, we have to put that int on it there, which makes whatever the outcome of that calculation is, adding those together or subtracting it if it's a minus value, we then take the whole number that comes from it. Then we do a little bit of color correction here. Now there's a little bit of issue that when you're on the blue value, if the blue value goes below 0, sets it back to 255. So I had a bug in the code to begin with. As we went through this, suddenly you got a bright flash as the color changed, and that was because of this. So I could probably do that for all of the colors, but this stops it going higher than the value that it should be for the colors. So it says if when we add that delta to it, it goes over 255, then just set it to 255. And likewise, if it's a minus event as well, it will make sure it doesn't go lower. Make sure it won't go into a minus color value, because that will then give a funny color, a different color on that. A little bit of a output there. So I'm saying if we're at the dawn 1 phase, then just put the timer out. I use that for diagnostics down here. So whenever it goes into dawn 1, let's set that. It'll go into dawn 1, and then it just shows you how the timer will change over time. It only does it once actually, but yeah, here we go. Yeah. So the first time it goes in, and that just shows how it changes over time, and you should be able to see the numbers changing there. But that only happens if we're in the dawn 1 mode. Now we can use that for other things, because if say we wanted to connect some other LEDs to the Unihiker to do different things, so like have little lights in the Book Nook, something like that, you could say if I'm in this particular mode, turn that pin on to turn that LED on. So this is like the main color of the Book Nook and what's inside it, but you might have little feature lights within it, like a little candle in a window or something like that, or some mysterious blue lights or something like that in different parts of the building, which happen at different times. So you could use that to check and do specific other events with a Unihiker with different pins when you're in different modes here. All right, so after that, it's quite simple. Make sure we add one to the timer, because we use the same timer for both the wait mode and the fade mode. It doesn't matter, we use the same one as long as we remember to reset back to 0 every time we change the mode. So if the timer is bigger than the maximum fade, then make sure we set the current color to the future color. So at the end of the fade, it's exactly the color that we want it to be. Then we add 1 to the future color. Make sure the future color hasn't gone over the maximum colors, and reset the timer and back into the wait mode. All right, so I hope that's of interest to you. I'll put this code on my GitHub after I've published this video. So you can see there we've got this opportunity to use the Unihiker to control LED and other events inside a Book Nook. It's interesting as well that we might be able to get the Unihiker to play sounds. So if we maybe had an extra button that was lightning mode, so when we got to the end of the night in the pitch darkness, we might flash a white light as if it's lightning. We could have that button down there to do that. We might even be able to load a sound sample onto the Unihiker and play a little note, a little something like that to make the thunder sound as well. So that's something maybe we could do in the future. So it's quite useful having this. It's nice to be able to do this with the Unihiker. Maybe it's not the best application for this. I mean, the Book Nook needs to be a feature when it's dark in your room, maybe. Having this lighting on probably doesn't help. Maybe we could find a way to dim the screen when it's not being used. So this would be driving it. Then if you tap the screen would light up, and then you'd get the buttons to change it into different times of the day. So I hope you enjoyed this. Please like and subscribe for more. I'm probably going to, for the next video, look at the Arduino code that I did for my Book Nook as well, and go through that and just show you the differences with that. But the Arduino code just steps through the colors, doesn't do anything else. So we can't jump into various different modes of the day and night thing on the Book Nook. Thanks for watching this video. Sorry about not being able to show you me coding it, but I ain't doing that again. I'm not starting to do that again. It's been quite a while for me to get this Unihiker thing working, and I think it has caused me a bit of grief, which is why I spent a while in releasing this video, and then I re-recorded everything for it and then lost the audio. So I just didn't want to do it. So I had a bit of a break, a bit of a gap from recording things, and I'll come back later. So I'm waffling too much now, so all there is to say is bye.